anywhere near what would you think? It was very close. How would you say it?
I generally say Boisano.
Boisano. Okay, he says it Boisano. That's close. That's fine with me too. All right, so I'm not going to steal any more of their time because they don't have much time, and it is fantastic to have them with us. Thank you, three, for being.
Nice. Okay. Hey. All right. Hey, everybody. I'm Brian. Hey. So what's up with this thing? I'm terrified of this clicker after 3 days of it. Let's see here. I'm in. What am I? James, knowledge base mode. Awesome. Yeah, I'm Brian Hughes. Click. Let's do it. Is it a delay? I didn't mean to if I did. No blame, please. Let's see. Okay, maybe I'm pushing the wrong. What's the one on the right? Isn't that true? Am I in mouse mode? Am I? Help me out here, Michael. Thanks. Okay. Click, please. Sweet. That's what I wanted right there. Brian Hughes, I'm president at Sologic. That is a new title to me the last couple of weeks. I'm very excited about this, but as time goes on, I realized that Mr. Chris Eckert, who's now our managing partner, might have pulled a fast one on me. The emails are nonstop. The work scope is increased immensely, but I'm so happy to be here with you folks today. We got John Boisano as well. John's the vice president. The three of us actually started Sologic back in 2011. And Sologic, for those of you that don't know, we started out as root cause analysis, root cause investigations, root cause training, and then also software. And I think what I wanted to say was, come into a conference, this conference in particular, I was going to say come into a conference like this, but there's not really a conference like this. The first time I came, I was like, oh, I'm like with my people. I love it because I felt like I just sort of existed out there. Like we would just like we didn't really talk to our competitors, the people that are doing things that are adjacent to us, the people that are doing things that sort of are complementary to what we're doing, or the things that we complement. And it felt great. And I've made some great friends. And as I look around the room, I see a lot of smart people. We've made a lot of new friends on this trip, but I find this conference to be extremely valuable because it causes us to learn. I was talking to Charles before, like kind of outside the door as the last group was finishing up. And I'm like, man, I hate sitting in these presentations before our own because everything that I'm learning makes me want to adjust what is on my slide. I've been practicing already, and I got to change it up in real time. So there are a lot of you that are first time. That is so encouraging, let me tell you, because this is a small group. It feels kind of big at the moment, but when you think about the scope of how far, the kinds of things that we're learning, the kinds of things that we're discovering, and the kinds of things that we're doing, we collectively, not just us. Yeah, you can advance the slide. That works good. It's probably the right time. Think about how many problems there are and how much learning there is to do. Yeah. We're good now. Thanks, brother. All right. Let's see if that. Whoa, it's awesome. It does work. So when you think about how many problems there are and about how things are rapidly changing and rapidly advancing and how much complexity there is, it's just going to breed problems. It's like living in the world today is a target-rich environment for all the kinds of stuff that we do. This really ought to be a conference where we have 2,000, 3,000 people, and even then I would consider it to be small. So those of you that are brand new this year, good on you for coming. Come back next year. I guarantee you'll get a lot out of it. Bring a friend. You know, let's see if we can't double it. I think that should be doable. Then the slide that you see up here, actually I got to walk over so I can talk to it. I pulled this together last year, but it's, you know, the first time I came, I felt like, man, because it was HPRCT, right? So you human performance, root cause, and trending. And it felt like we were very siloed in a way, like, oh, we were the root cause guys over here. You got the human performance people, and then the trending folks, and whatever, the resiliency engineering people and all that sort of thing. But really, when you start listening to the people talk and share what they've learned, well, there is a lot in common. There's a lot of overlap. And now we all bring something different to the table. I like to think of it sort of as it's almost like a potluck. And, so yeah, we bring our special thing and thing that we like, and then we get to try everybody else's, and we get this plate full of awesome learning opportunities, and it's changing us as a company. And I thought, well, how do we all come together? And so this is kind of started out as a dry erase board, then it turned into an ugly PowerPoint, and then I actually got somebody to kind of doctor it up a little bit. I think the commonality between what all of us are doing, if we were going to sort of boil it all down, is we're trying to help people determine what to do best in the present, because in this present moment is the only time when we can do anything. You can't undo the past and you can't pre-do the future. You can only take steps right now. And so, but how do we know what to do right now? Well, that's kind of what we're all here doing, is learning about how to learn about what we're supposed to do right now so that our future is the future that we like better. And so sometimes some of us do that through the lens of root cause analysis. Some of us do that through the learning teams, or some of us do the human and organizational performance stuff. Some of us are maybe experts at data visualization, tracking and trending, and all of those different things. But all of them are focused on helping us make better decisions right now so that we have outcomes that we like better. And so the way that this graph works, I think I need to talk to this just a little bit more. We look backwards a lot of times to see how things worked and kind of deconstruct them so that maybe we can have a better understanding of them. But when we look forward, there's a lot of uncertainty in the future. There's less uncertainty in the immediate future, but the farther out we go, then the scope gets bigger and bigger. That's not necessarily always a bad thing. Sometimes good stuff comes out of uncertainty, but sometimes not. And what we really want to do is, I guess, have a better understanding of what that uncertainty is and what causes it, or what the contributors are and whatnot, so that we can have a little better control. So if we have a clearer understanding or clearer visualization of uncertainty, then we're going to act to actually reduce some of that uncertainty. We can do things to prevent it. We can do things to anticipate it. We can do things to detect it or to mitigate its consequences, et cetera. And we never know exactly what's waiting for us out there, but something is. And the more that we're able to know right now, then the better able we are to make decisions. And I kind of feel like, even I could probably say it a little better, but I kind of feel like that's the thing that all of us could sort of get behind. So even though we bring something different to the potluck, come on, you. I love being, I saw all of you all. There it is. The potluck, there it is. Then we all get a share from the plate, all right? And that's probably enough on that. But I do want to invite a new participant to the potluck, and that was that we didn't use body parts to pull this thing together. I just want that said. Charles used the Frankenstein monster. It's something that we were working on, but it's not that. We're working with AI components to help bring something new to the party. And so artificial intelligence, I mean, we all have heard the term, and actually all of us interact with it all the time. You know, these little data gathering devices that we carry around with us, these things are collecting information. And then, but what goes, like, how does it know, for instance, how does Facebook or LinkedIn know what I might like in my feed? Or how does Google know when I might want to go home, or what the best route is to get to a certain place, you know? And so under all of that is there's a lot of artificial intelligence going on there. And that artificial intelligence can be broken down into 7 different patterns, basically based around use case. You know, so things like hyper-personalization it's like, man, if this thing feels like it knows me. Well, it kind of does. Alexa, right? That technology behind Alexa. Recognition, like the facial recognition that, I mean, I use to turn my phone on, or conversation and human interaction. So all of these are different versions of AI. The ones that I have left up here are the ones that John and his team have plugged into our CosLink software. We're using our software today. Please don't take this as a sales pitch for CosLink. It's just the only thing we have, right? So like, that's what we're working with. That's our little laboratory, and it's our thing. So that's what we're presenting and what we're going to be sharing with you. But these are the different AI patterns that you're going to see demonstrated later today. And the purpose of this is to create like a new participant in the process of learning, a new participant. Not necessarily, this is not going to be something that takes over, but something that helps us because it's got some really unique capabilities that are not humanly possible. And so if we allow that, or we invite that entity to the table, then hopefully that's going to make what we all do better. Okay, so hopefully that kind of sets the context. So I thought I would share a personal story to illustrate this slide. I didn't know Rob Fisher. Rob, he's not here any longer, but I learned a lot about Rob today, and I really loved his presentation. I didn't know that his mother passed away from a medical error. My own mother passed away from a misdiagnosis 14 years ago, almost to the day. My brother and I, we had to decide to, discontinue treatment after she was in septic shock from Clostridium difficile infection that she got in the hospital. The misdiagnosis was that this C. diff infection was not treatable by antibiotics. It was antibiotic resistant. So really sad. And when I look back on that, I think, gosh, like with any tragic event or even little things, it's like, man, could we have known more? What could we have known at the time that would have allowed her care team to have made better decisions, or to have maybe had better information? Because we didn't blame them. They were doing their best. That stuff just happened. So 90% of an organization's data is unstructured. And by unstructured, I mean, it's like just there in Word documents, Excel files, PDF files, emails, all that kind of stuff. But what if some of the causes or contributors of future problems are already known or knowable, but they're just buried in that needle, and they're like needles in the haystack? What I was going to ask Rob, but then he left. But those of you that have been in this business for a long time, how many incident reports have you reviewed over the course of your? Newman, you're here in the front, brother. So, how many incident reports have you reviewed over the course of your career? 500. Yeah. So artificial intelligence would do that in a nanosecond. Now, would it be right? Maybe, but it's going to identify patterns and anomalies and interesting things that we're simply not capable of. Now, so I'm going to shift gears just a little bit here, and I want to talk about a single event. I'm going to boil all this down just because it's nice to have a simple starting point, and before we scale up to talk about things that are more complicated. And I love the concept of spilled water, because usually there's a water glass sitting close by, so it's something that we can all visualize. Let's say that this happened and I'm like, oh, that's the worst part of my day. I spilled my water. I'm going to spend some time to investigate that and to figure out why that happened or how that happened, because I don't want that to happen again. And the way that we do that is we start out with that thing that we want to understand. And by the way, it doesn't always have to be a bad thing. And it's kind of a bad thing, but whatever. It's an event, though, I think is the way to think of it. And in this case, the event is spilled water. And I'm going to look at what James Newman, I'm going to just use you the whole time because you're sitting right there, what he would call the causal antecedent, or the thing that happened just before the water spilled. In my mind, I think about rolling it back one frame at a time. And so right before we had spilled water, we had something that looked kind of like what's on the front of this table, which is a glass of water, right? But the glass of water, you got water in it, it's an opening at the top, but it's not spilled because I haven't actually triggered the spill yet. And so what we do when we think about events and when we're breaking them down to look at the ingredients or the causes or the conditions, is some debate about what language to use. But the way that we look through this lens is that if I upset a glass and there's water in that glass and there's an opening at the top for the water to go out, then I'm going to have spilled water, right? So I'm just kind of like storyboarding these. If you imagine like a film here, and each of these are different frames, and I can go backwards and backwards and backwards, et cetera, right? And I get something that looks like this. Now, is this the event? No, it's a model of the event. It's like an outline, right? So all of these books that are up here, I'm going to grab Mr. Mishara. This is great, by the way. Tony Mishara, Ron Ferris, Jim Marinas. If I go to page right up in the front of it, there is look at this, one-handed, nervous, freaky clicker, and still successful. What would you call this, James? A table of contents. Well, a table of contents is an outline of what everything is in this book. And then it's really a useful tool. Do you learn everything that you need to learn from the table of contents? No, just like you don't learn everything that you would learn from an outline. But the outline itself helps us understand and explain. It's a tool that allows us to explain, the story of this particular event. Now, it's not different from what a lot of us use. I graciously, and I'm really sad that he's not here, but Bob Edwards isn't here. But Bob, he's just one of the greatest guys. If you have not taken Bob Edwards' Learning Teams course, or Andrea Baker, for that matter, these are fantastic folks with a lot of good information to share. But what I love about this is how similar Bob's representation of how events occur, like lots of different inputs, lots of different things coming together. They're diverging as they go backwards in time, converging on the event. Well, they're very similar to this model. So are they exactly the same? No, but I'm just kind of showing that, while we might have different things that we brought to the potluck, well, then at the same time, it's just a little different way of thinking about it. But it's more conceptually underneath it all, it's all pretty similar. But as we do this, as we come up with these different models and these ways of sort of helping us understand events, I was thinking, man, lately what I've been doing, and this has been the biggest gift that I've given myself this year. I've been a bass player for 35 years or so. I always played and I love it. It's fantastic, but I never took a lesson, and I never knew how to read music really. And so this year I've been giving myself the gift of bass lessons, and I've been learning so much and learning how to read a tabular chart like this. This is the song Blackbird by the Beatles, right? Does that sound like Blackbird to you? James, you want to karaoke it out?
No, that's all right.
What? Oh, don't give me details. I'm selling concepts, right? Blackbird singing in the dead of night, right? You can kind of like overlay that and use it to understand what it is. One of the things that I love about this is that the notes that you see up there are absolute. A is A is A. It's a frequency. But the patterns, the way in which the song goes together is actually relative. So you've got through that knowledge that if you know what you're doing when you look at this, the person that played for us the other night, she was fantastic. If you wanted her to play Blackbird, you could just ask her to do so. She could pull this up in the real book and she would be able to hammer it out. She would have to have a little more information, but it's that same sort of usefulness that we find in models. I'm going to shift gears and talk a little bit about how repetition and use of a model and refining of a model leads to intuition. And so this is a quote that I took directly from one of the books that's sitting up here. This one that I actually just grabbed, Critical Steps by Tony Mishara, Ron Ferris, and Jim Marinis. Intuition is a perception of a situation without the support of conscious reasoning, thinking that is ongoing yet unconscious. So that's soak. What makes it intuition, expert intuition, is the depth of knowledge and the experience accumulated by the individual, recognition of patterns over time. Chris and I have been working together for 22 years. John too, for that matter, in different capacities, right? Chris and I we're the practitioners and we're the people out in the trenches teaching, investigating, doing. I remember sitting around and it's like, well, what makes us good at this? And how can we use that in our class to help make other people, how can we make them like us faster than it took us? Because it took us a lot of mistakes and a lot of trial and error and a lot of learning that was there. And it's like, yeah, but we see things through patterns. That's the thing that makes it faster for us. And so if I go back to my spilled water example, what do I mean by that? First off, this event will never happen again like this. This is a one and done, just like all events, right? So you never see the same river twice, sort of thing. Well, yeah, fine, but abstract it up a little bit. There's a pattern here around spills. Okay, so now abstract up just a little, one level up. And can you imagine a can of gasoline spilled in the garage? Maybe you use it for the lawnmower, and how similar that might be to a glass of spilled water. Completely separate scenarios, but kind of the same. Also, as I work my way through, like when I upset the glass, that's an event where something moved or something was disturbed. And I can see some patterns in that too. Something getting upset or something getting moved because some force was applied and that force was enough to move it, and so on and so forth. As I go through, Chris and I, what if I can speak for Chris, I think I can. What we see when someone talks to us about an event is we're listening to the details, but we're also comparing it to the abstract models in our mind. And that abstract comparison is super helpful All right, well, let's bring our buddy artificial intelligence into this. Don't you think that if we were going to try to get artificial intelligence to understand causality in the way that we do, that maybe we would try to get it to also recognize these patterns? And so that's kind of where I wanted to lead up to. I do want to say one more thing. I'm going to pass this off to Chris here real quick. I had this thought this morning, along with a lot, but I'm going to fit this one in because I'm almost at the end and I love seeing it's like the runway. I think I'm going to make it. All right, so if you're not able to abstract commonalities between what we've learned from in the past, you are unable to do any kind of future prediction. That's because this event will never happen like this again, this spilled water, but people are going to spill water. Okay, so you need to use the abstraction along with your imagination, along with your diverse team members, along in your learning, whether you're in a learning team, root cause analysis, or whatever it happens to be, you're just sitting around the table, just yakking. You need to use your abstractions and then apply them to potential future events to think about, well, hypotheticals, what could happen? How bad might it be? And then to come up with ideas for how to either eliminate, prevent, or to reduce the likelihood, or to mitigate or provide earlier detection or whatever, such that you're reducing that uncertainty so that you can make a better decision in the present. And that brings us all back to that slide where I think that that's where we all are. I love all you. Kumbaya, all right. Okay. So that's my part of this presentation. I'm going to pass it off to Mr. Chris Eckert, and thank you guys very much.
Thank you, Brian. How many people know this guy or you met him? Okay, I need the clicker, thank you. Of those people who know this guy or have met him, would you be surprised if I told you he just used up twice allotted time? I know you're not surprised by that. All right, so
Sorry, I'm sorry. Yeah.
they brought me along for the Professor Obvious moments. That's what I do best, right? So briefly, why are we doing this? Why AI? My Professor Obvious moments. One of the things that, again, picking on James Newman, we were talking about this on Monday. He called it the silver tsunami. I like that. That was cool. Thanks, James. As you know, the subject matter experts are disappearing. Many of you are those subject matter experts, but many of you jumped ship. You retired, you took a new role as a consultant expert. The expertise is out there. It's now in a different place. And one of the challenges, and we all see this, the incoming people, sharp people, but they don't have the depth of experience. They don't have that range, and it doesn't appear that they're going to pick that up. They don't stay in these positions as long. They don't have as many opportunities to get the depth. And those career paths for most organizations just aren't there anymore. We think AI can help with this. Another problem that we're seeing, again, you guys see this, it magnified in COVID, people have less time, yet the problems are still there and getting more frequent. We're just trying to get through the day, right? This problem was layered on top of the brain drain accelerated by the Great Recession, when inevitably a lot of the people took early retirement, outplaced, whatever. When those things got layered on top of each other, we really started seeing problems. I just met Teresa Swinton yesterday, and we were talking about post-recession, what we observed. Problems have always been around. We've always been solving those. But what happened is the magnitude, the impact of the problems post-recession started getting huge. The causes were largely the same. One of the things that happened is all those SMEs that used to be around who could see and spot incipient problems percolating up, they'd intervene. They used to stop us. Hey, we need to course correct. They weren't there. So those problems went undetected. They got bigger and major incidents, major problems. So we've got this challenge. And then one of the other things that's happening is more information is at your fingertips now than ever. The learning teams, RCA teams are generating some extremely valuable information, but what are we doing with it? This is going to be a challenge that we have to deal with. If we're not doing something to make that information easily retrievable and sharing it, it's going to get lost. Charles started the session this morning by asking the question, tell your buddy 3 things that you've picked up the last 2 days. A lot of good stuff, right? Last 2 days. Is your brain having trouble processing, absorbing, and remembering? Mine is. I had to think a second. 3, it's like I've heard all this good stuff, and I'm like, okay. Imagine if Charles had said, give me 3 nuggets from every presentation. Oh man. Imagine if he posed that question to you 3 months from now. That's going to be tough, right? You're going to remember cool. Cool is going to be on your brain, but it's going to be tough for you. How do I get that back? We think AI can help with this. Tuesday, Laurent DeJulian, hiding back in the corner, gave a talk, really nice talk on communications and how are you effective at getting your message to different generations, different diverse folks. She said something that was very subtle, but very important. The information has to be a way to get that to the next generation. Couldn't agree more. All the cool stuff we're doing with learning teams and RCA, we got to figure out how to get that passed down. And just as you are seeing and hearing all this cool stuff at the conference, you're going to have a hard time accessing it. Imagine, this is what always happens, right? You hear all this cool stuff at conferences and wow, that's good stuff. But you don't need it right away. You're going to need it 6 months from now. 6 months from now, when you need to tap into it, you're either going to pull your notebooks back out or your phones because you're snapping photos and you got to find it. A lot of information to sort through. So what we need to do are create pull systems. When you guys want information, how do I cook chicken cacciatore? Siri, how do I cook chicken cacciatore? Boom, there it is. That's what you want. You don't want people buying you 15 cookbooks to store in your shelves when you don't need them. So pull systems are information you need at that moment that's relevant to your situation. We got to focus on that. Push systems are what many of us are still working in. And for those that are generating a lot of cool information on the learning teams, I want you to think about this. Push systems are when that information is sent out with mass email. Or, hey, go visit the shared drive. We just put all that up there. Good stuff, but people are overwhelmed. Push systems in my world, even though they're sharing a lot of good stuff, is this. And I think this moniker gave spam a bad name. I don't know how much you guys feel about it. I like spam. I kind of denigrated spam, you know? Good
Spam
stuff.
rules. I love it.
AI can help us with that communication. Wrap it up here. One of the other things, how many of you have heard from your colleagues that you want to do a learning event, an RCA, whatever, don't have time? Right? That's real, right? We got to solve this problem of time. Are we going to be successful at solving that problem? Probably not. One of the things we have to do is make it easier. AI is going to help us make it easier. Remember 20 years ago when you were going to take that cross-country trip and you're planning your route, what did you do? You pulled out the atlas. Remember the atlas? You looked at the globe, or the, if you're in North America, the US, North America, and Canada map. You first got the big picture. Then you flip to the page on North Dakota, right? All right, we're going to take this route through North Dakota. How many people are good at reading maps? It's kind of some of that reptilian brain. A lot of people are good at reading maps. A lot of people aren't, right? Remember who used to do the map reading? The person in the car who is good at reading maps. I'm lucky. I've got a very developed reptilian brain. That's about the only part of my brain that's ever developed. I'm pretty good at orienteering and things like that. My wife, on the other hand, not so good. This equalized us all, didn't it? The great equal, my value in the relationship dropped precipitously when this came out. Reading maps, navigating, it's kind of sort of heavy lifting. We have to figure out how can we do this, right? So now I go, Siri, give me directions to Fargo, North Dakota. After I answer the question that Siri poses back, Chris, why do you want to go to Fargo, North Dakota? it gives me choices. It gives me 3 routes. And I'm looking at the routes. I'm like, oh, this one goes by the North American Bat Guano Museum. I'm going to stop by the North American Bat Guano Museum, and I can punch that in. That's the power of AI. And further, it warns me that there's a backup of traffic on the way to the North American Bat Guano Museum. So this is the kind of stuff we got to get to. It provides real-time positive input and help on how we can get there. So we need to do that with our learning team reports, our RCA reports, make it easy for people to do that. AI can get us there. We also need to reserve that time. John, I'm going to turn it over to John Boyson in a second. He's going to show us what we've done and how we're going to make it easier and faster and simpler and proactively give people information that otherwise may not have been present. We want to keep your people involved. Your people are always going to be involved. There's no doubt. But what we want them to do is work on the high value part, the thought, the unique information that they need to introduce that the AI model really won't be able to help you with. So we want to shift the time, get rid of the low value, heavy lifting, keep them focused on the value add stuff. But that's really what we're trying to do. So at the end of the day, we're going to use AI to make it simpler, more effective, and more timely to help your people solve problems, because that's all of our goal. In 2017, we started dabbling with this about 7 years ago. And in 2017, we gave a presentation at the conference. What are we doing? Where do we think this is going to go? We've changed a lot since then. So it's not a consistent carry through. We've had some starts and stops, and we've scrapped some stuff. John's going to talk about what we've learned. But at that time, we were using IBM Watson, and we were looking at pulling causes out from incident reports. We did some pretty interesting things. We were feeding in frontline supervisor incident reports or narratives, and Watson was able to extract causes quite accurately that then got put on the chart. We did some other stuff too, the solution evaluation, things like that, but those were the big ones. At that time, we suspected what we were thinking, we can get AI and artificial intelligence and machine learning to help us take the burden out of building cause and effect charts. And so John's going to show a little bit about what we did. But at the end of the day, we had an open playing field. We didn't quite know where to go. We've turned courses, but we're taking a shot at what we think is going to be able to help people be more effective at solving problems in the future. So with that, I'm going to shift it over to John, and who's going to lead us through that.
Okay, thank you, Chris.
I think you took twice as long, Chris.
All right. Well, let's circle back to the question. Will the machines take over? Well, these guys are saying yes, but not today, right? It depends on the time frame we're talking about. Are computers going to be smarter than humans in 10 years, 20 years, 30 years? This is the trajectory we're on, right? And what do we mean by take over? Is it going to be like something we've seen in the movies? Or are we all going to be kicking back in hot tubs while the machines do all the work? That sounds pretty nice. What we know is that machines and algorithms, they're already a big part of our lives, right? We use Siri and Alexa. Maybe your car gives you a nudge if you cross over the line, or maybe you have a robotic vacuum cleaner in your living room. These things, they make our lives more convenient, and in some cases, they keep us safer, right? Like any tool, technology can be used for good or bad. And of course, today we're here to talk about how we can use artificial intelligence to help people solve and prevent problems, right? And so, in addition to asking that question, we're also asking, how can artificial intelligence improve organizational learning? And as Chris mentioned, this is something that our team looked at in 2015 when IBM opened up their Watson API to developers. We experimented with this system and we learned a lot, and we've continued learning. We also a few years ago at a conference formerly known as HPRCT. We presented a poster board session where we were showing how algorithms can help you find common causes in a large data set. And so we've continued down this path. And today we're excited to show you our latest work. Before we do, I want to talk a little bit about the technologies we're using, because Sologic and a lot of companies like us, we're standing on the shoulders of giants. There are large organizations with tremendous resources that are providing some pretty mind-blowing tools. And the cool thing is that, you know, anybody, essentially anybody in the world, most anybody with the idea and the skills and the gumption, they can sign up and access these tools and bring their idea to life. And I think it's pretty exciting. And we certainly are excited about the opportunity. So we're going to show you a demo at this labs.coslink.com. This is our experimental site where we try out new things, we get feedback from people, and decide what goes into the final product. Today we'll be showing you voice to text and narration, how that can help with filling out online forms. Oh, skipped past a couple there. Had to get a little clicker forward there. Cause patterns and how that can help with cause and effect analysis, and how also the system can suggest solutions based on your analysis data. And then finally, how it can summarize your reporting for you. And so with this, I'm going to walk to the back of the room, and I'm going to run the demo from there because we can't have a computer up here. So bear with me. And as we do, as Brian mentioned, we are pulling this up within COSLink software. This is a system that we built that helps people solve problems using root cause analysis and other tools. So bear with me here while I get my glasses on. All right. So the first feature I would like to show you, this has to do with online forms. And we built this because, you know, online forms, they can be cumbersome. They can be time consuming, right? Especially if you're out in the field with your mobile phone and, you know, hunting and pecking to try to fill this out. So we thought there's got to be a better way. Why not make this more like a conversation? So here's how it works. We created this new quick start page.
What would you like to name this new record?
Recordable injury. So the system uses narration to ask you questions, and then you're gonna respond with your voice, and it turns that into text, right? So people will be able to set up whatever questions they want. And for the end user, you know, you can decide, you can turn the narration off if you want. You can type into this if you want to, but we think it's a pretty fast and easy way to get your data into the system. I'll do a few more.
When did this happen?
June 15th at 2:32 p.m. Mountain Time. I find it very accurate. And I've been using voice to text on my phone and trying it out on the browser for quite a while. And it's very accurate, and it's been improving over the years.
When did this happen?
Colorado Springs, Colorado. Now, sometimes you need to come in and do things like add a comma, but it saves a lot of time.
What is the investigation focal point?
Employee cut their right hand. And so, you know, I think you get the point that it's makes this really easy. It's kind of like having another person there really just interviewing you, and you're just answering questions. You're hands-free, and you don't even have to be looking at the screen if you don't need to. So you can start the analysis, and then that's just going to write that information to the database and then kick you right to the default template right there. So it makes it really easy. The next feature I want to talk about has to do with cause and effect analysis. And, you know, Brian showed this a little bit on the screen where you're going to be coming in and adding causes to the system, and you can describe the problem in detail and, you know, fill in these Y boxes with the details of your problem. That opens up all these causes to potential solutions, corrective and preventative actions that are going to prevent this from happening again. Well, experts like people like Bob Latino, Brian Hughes, Chris Eckert, they have these patterns in their head and they just rattle them off and they complete their investigation quickly, right? Not everybody has that. So we thought, why not? I'm going to put these to the side here. Why not make it easier for new users or people who don't do this very often? You know, how can we help them get their jobs done more quickly? So what we did was we trained a model to parse through the text that you type into these boxes and then match that to patterns that we've pre-trained the system on and then present those to the user as options. So I'm just going to modify this and the system's going to look through my text. And when it finds a pattern that it's confident enough in, and we determine what that means in terms of confidence level, it's going to suggest this pattern to you. And you can, you know, as an end user, you can decide, does this meet my expectations or do I skip this? So you can confirm it. It writes that to the database, and then you can come in and fill in the details here, right? So if I wanted to come in and say, table saw was running, or, you know, down in this one, were they wearing protection or was a protection not required? You know, you can fill in the details. And in this case, they weren't wearing protection. That's going to trigger another pattern. And you can decide, well, is that going to make sense for me? I'm going to fill in the details. So, you know, we're still testing this out. We're getting feedback from people. But so far it's looking like, you know, it's going to make it easier for people, faster, and their analyses are going to be more complete. So we're excited about bringing this to market. The next feature I want to talk about has to do with corrective and preventative actions. And for this one, I need to pull up a completed investigation. So bear with me here. We did a case study on the Hubble Space Telescope a while back. When it was first launched into orbit, it was coming back with blurry images. And so we did a record on this one, and it's a fairly extensive analysis, you know, 93 causes on the diagram. And there's some solutions in here that that came out of this investigation. Now, the system that we have added this button that says suggest solutions right here. And what this does, this is going to look at all of the data for this analysis. And this data could be witness statements, it could be learning team notes, it could be the incident timeline or fishbone diagram. In this case, it's the cause and effect diagram. We send that to, we're using OpenAI for this. We send this to OpenAI. It's going to parse through that content, and then we ask it to suggest solutions. And so I'm going to do this. This is in real time, by the way. I hit that button. It's going to come back, and I'll zoom in so you can read this, but I'm also going to read these to you. Adjusting the settings on the HST to compensate for the spherical aberration, HST being Hubble Space Telescope. Manufacturing a new primary mirror that has a conic constant closer to the desired value, and use reflective null corrector to measure the mirror's sphericity during manufacture. So there's some pretty technical terms in here. Those are all pulled directly from the content. These are written by an algorithm, right? And they're very accurate in terms of what you enter into your analysis. As an end user, as a facilitator, you know, again, you get to decide: does this make sense? Do we want to suggest this or implement these? You know, think of these as really another person on your investigation team that's providing input. You get to decide as the facilitator what goes in and what goes out. You know, this is one of the features that's pretty new. We've only been had this for the last few weeks, but so far we're finding that it's, for one, highly accurate based on the data that you input into the system, and then, you know, for two, it's just gonna be very, very, very good sentences. It's amazing how well the system can write. So we're still learning, but so far we're liking what we're seeing. Let's take a look at another example. This one was a natural gas pipeline explosion. And if I go, you can see there's 45 causes on the chart, and there's 5 solutions that have been suggested. Again, let's see what the system's going to say here as I suggest solutions. I'll zoom in here so you can read that. Ensure that all service lines are properly cut and capped by contractors. Perform atmospheric corrosion tests on all service lines. Perform external corrosion tests on those lines, and ensure that all valves are properly labeled and easily accessible. So, I mean, again, this is directly pulled from the system, and some of these are they're also what the humans had suggested here in these 5 solutions up top, right? And that's fine. It's another, as the facilitator, you get to decide, does this make sense? Do I want to include it or not? But it's going to be, we see it as a safety net in that if you had entered something in your investigation, but you did not consider that in your corrective and preventative actions, this will catch it and it'll nudge you. Do you want to, maybe this is something that you need to consider. So far, it looks like this is going to be really helpful to people, and we're excited to hear what people have to say about it. Now, for the next feature, it's similar to this, but I want to talk about the final report. When you're doing an analysis, you often need to produce a final report, and that's going to summarize your findings, hopefully in a concise way that someone can quickly understand what's going on. That can be time consuming, to parse through all your data and make sure that you've captured the most important things. And so we ended up writing a feature that is going to help with that. And right now, if you look at the product, it ships with paragraph and outline. And these are helpful buttons in that they're going to look at the cause and effect diagram and write these out for you. But they're very verbose. You need to go in and edit it and make adjustments. So we thought maybe OpenAI can help with this as well. And so if you click on the summary button, it's going to do something similar to what the solutions did, in that it's going to send that data to the system and then come back with a summary of your investigation. And so this one's a little bit longer. I'll zoom in a little bit and you can read that. I'll read it to you as well. The natural gas explosion occurred due to a gas leak that was caused by a corroded threaded coupling. The gas leak was due to external damage to the coupling that was caused by human interaction. The human interaction was caused by individuals tripping on the bumping the service line. So I'm not going to read the entire thing, but I think you can see, this particular summary, this one needs a little love from a facilitator. You need to come in and edit that because it's a little redundant, but it's highly accurate. And it so far we're seeing that it's pulling the pertinent information out of your investigation or your analysis, and very helpful. It's okay if you need to edit a little bit. It's oftentimes a lot easier to edit something that's in existence than to create it from scratch. So we think this is going to be helpful. I'll show you one more example through this one right here for the final report. This is an outage in the Google data center. And if you look at the summary here, I'd pre-written this one for us to save a little bit of time. A router replacement caused increased latency for the Google compute engine traffic for 99 minutes. This was caused by new hardware not being configured to handle cloud traffic, and the traffic being sent to a single point of presence that could not process all the traffic. Very concise and very accurate. I mean, would you be able to tell that an algorithm wrote this? It's pretty hard. So far we've looked at things that help people with a specific investigation, right? But there's also value in looking across records in the system. Some companies have hundreds or thousands of records in their system. How can we find the common things or the systemic problems that you want to pay attention to and prioritize. So that's what these next two reports do. We built these new ones, common problems and common solutions. What these are doing, they're looking at a company's entire database, and they're looking for similarities in that data. And when they find those, they cluster them in these groups. And then we send that clustered data out to OpenAI and ask it to summarize this for us. And so that's what we see here. I'll zoom in. This one right here is my favorite. This is 53 records in a customer system. They had 850 records in their database. These are 53 that were similar. And here's the summary. It's a little bit morbid, but this is real data. Several employees have recently been injured on the job, sustaining injuries to various parts of their bodies, including their knees, feet, fingers, and back. In one case, an employee even suffered burns to their abdomen and lower extremities. These accidents have resulted in a number of lost time injuries. I'm going to read one of these sentences again. In one case, an employee even suffered burns to their abdomen and lower extremities. I mean, this algorithm knew that that was a special case that needed to be called out. You know, out of 53 records, that's something unique that we needed to call out in the summary. You know, I just found that to be amazing that it was able to do that. And this, you know, it's writing this entire sentence. And so we think there's a lot of promise in this, and that it's going to help people, you know, understand what the common issues are in their organization. That's going to help, you know, with their current staff know what to look out for. It also could be a great training tool. As someone comes in, you could help them understand, here are the common problems that we've run into in the past. You know, let's look out for these things. Another report is the Common Solutions report. And this one it's similar in that it's going to look at all the data in the system, but it's going to pull out the corrective and preventative actions, and it's going to find the similar ones and summarize those for us. So here's one of these. Here's an example. The company has been trying to solve the issue of valves leaking through by replacing them, changing the valve type, or repairing them. They've also changed to motor operator valves in some cases. In other cases, they've replaced the nozzle or the piping. And in one case, they changed the actuator valve assembly design. I mean, if I was managing this team or this division, you know, I'd want to ask, you know, why are we solving this in different ways across different parts of our company? Or maybe that makes sense, but at least you have the information at your fingertips to be able to have the conversation about it. So, you know, imagine having to, you know, read through hundreds or thousands of records to find these similar problems and bring that to your team. So we feel like it's going to be a big help. And so in closing, I'd like to just say, you know, we feel like artificial intelligence applied here, it can be a real help to people who are trying to solve problems. And we feel like, you know, this is something that is still new to us. We're still learning, but we're looking forward to what's next. So with that, we'd open it up to any questions that you may have.
I don't know that we have time.
No, not at this time.
Yeah. So,
If you
Are
have
we out of
questions-
time?
yeah, we probably run out of time, but we will be more than happy to talk with everybody. And we really appreciate your attention today and appreciate being able to present and share with you what we've learned.
Thank you.